Welcome to the Computer Club, everybody. I'm going to give a quick introduction to Python, the syntax, the structure of it, which will lead into Ryan talking about Python specifically for hacking purposes. Well, obviously, the first thing you're going to need to do is install. Normally, for the first session, I would just advise using an online compiler, but I believe you're going to be using PwnTools, which you cannot use in an online compiler. So you're going to need to go to python.org/downloads and download whatever version of Python you see fit. Probably the newest version would be the best. So once that runs, the main thing you're going to make sure you do is add python.exe to path, because that means you can use Python, the command, in your command line, which is important for actually running Python. So this obviously takes some time for people to download, so I'm just going to start talking about it while you download it. For what I'm going through, you can just use a random online interpreter for Python, so just Google Python interpreter and type in what I'm telling you to type in. It'll work, but for the later part of this, you'll need to be able to import libraries. So yeah, I would advise downloading this as soon as you can. So this is just what you're going to do to check to make sure your Python's actually downloaded. Once you've installed it, just go to your command prompt, type in Python tag version, and it'll, if it gives you something that looks like this, that means you have Python installed. If you have anything other than this, that means you don't have Python installed, and I can probably help you figure out what the problem is. So, what is Python? Python is a high-level interpreted language that's made for readability and simplicity of syntax, right? So the key features are it's going to be readable, easy to learn, interpreted and dynamically typed, which is something I'll go over. And it supports multiple programming paradigms, right? So if you want to write an object-oriented project, you could do it in Python. You could write a procedural, or you could write a functional programming project. And the biggest thing that gives Python an edge is going to be the standard library and the ability to import modules very, very, very easily. So basically, the basics of it, I have 4 lines on the right here. The top line is the print function. You call a function just by typing the name of the function and the parentheses, and you give it whatever arguments it needs. It's dynamically typed, like I said earlier. So for the lines x equals 10 and name equals Bob, you don't have to type int x equals 10 because it just infers the type from what you're giving it, right? And obviously Bob is a string. You don't have to tell it it's a string. It knows what that is. And to do a comment, you just hashtag at the beginning of the line. So yeah, the data types you have available to you, while it is dynamically typed, sometimes you'll have to learn how to cast things. So that could be important. You have integers, floats, strings, booleans, lists, and dictionaries like you do with most other languages. If you're unfamiliar with what a dictionary is, it's just it's a data structure with key value pairs. So you can look up items in a dictionary based on a key, and it returns the value associated with that key. So if I tried to access the key that is associated with the string key, it'll return the value as a string. So control structures. This kind of emphasizes how easy Python is to use. You use indentation. You don't use curly brackets to separate code blocks. So in this case, we have if, elif, and else for if, else, if, and else. And the indented lines are the code blocks that are going to be run if that condition is met. Yeah, you just have to add a colon at the end of the line for your conditional, and the next line just needs to be indented 1 extra tab, and it'll work. So in this example program, I use an if, elif, else conditional, basically just exactly how you would use it in any other programming language. It checks a condition and runs the block of code depending on the condition. Yeah. It knows what it is, yeah. That would be a value error because you're not able to. It'll return an error. It'll print something to the screen. That's one thing that Python's also pretty good at is the debugging. It's going to tell you exactly what you did wrong, what line, and where. But yeah, if you tried to assign it to a string, it would just say you cannot assign a string to an int. But yeah, that makes it a little more difficult to deal with. But it also makes it easier to read not having types. So that's what they're going for. And then, yeah, similar idea here with for and while loops to C. You'll use the for or the while keyword. And instead of needing to put the actual condition or the, the amount of time it's looping in parentheses, you can just say for I in range 5, it'll run it 5 times. And while X is greater than 0, it's exactly what you would expect. That's the condition. No need to put it in parentheses or anything. Functions. So we define functions with the def keyword, def, and then the name of the function, and then parentheses containing any parameters you want for that function. And again, like a conditional, you'll have a colon at the end of the line for the name, and then everything indented after that colon is going to be in that block, right? So in this case, I define a function called greet, and it takes in a name. Again, I don't have to specify what type name is. It infers it based on what I'm doing with it. So in this case, it'll append the person's name to a string hello, so it infers that name has to be a string. And then I call greet Bob. And then I also have some other examples of common functions that are built in that you will absolutely need to use at some point. So I define a list using the square brackets with the values 1, 2, 3, and 4. And length and sum return the length and the sum of the list. Obviously, if you try to sum up a list of strings, it's not going to be exactly what you expect. But a list of integers like this, it'll sum it up exactly how you would think. It's going to be 4 plus 3 plus 2 plus 1, which is 10. And length is just going to be how many elements there are. Pretty simple. And then the last one you're probably going to have to use is input. So input returns data from standard in that the user enters into their console, right? So the parameters for input are going to be what you want to print as a prompt. So if I input enter a number, it'll print enter a number and then ask for input, and then it'll return it to where you called it. So ideally you want to assign this to whatever you need to deal with, right? Working with libraries, like I mentioned earlier, modules or libraries, they're synonymous in this case, is one of the places where Python shines. If it's not in the standard library, most of the time it's as simple as running the command pip in your command line to install the library and then rerunning your code and it'll work, right? So popular libraries are going to be the math library, which includes a lot of the stuff that you need to do in math, but isn't built into the language by default, or it is, and it's just a little contrived to try to get to that answer. So in this case, I import the math library with the import keyword, and the name of the module or library is math, and I print the math.square root. So the dot is accessing the square root method of the math module, and then supplying it with the correct input that I want, right? And this will print 4, as you would expect for the square root of 16. So I have an example program that I'm just going to run through in case there's any confusion. Stop and ask me questions, and I'll ask for questions after. So in this example program, at the top, we use the import keyword to import random, another library that is used semi-commonly. After I do that, I define a function called check number, which takes n as an input. And in that function, I print using string interpolation. So if you precede a string with the lowercase letter f, you can use something similar to how format strings work, where instead of doing %d, you would just do curly brackets, and inside of the curly brackets, the name of the variable you want to print. It interpolates it for you. One of the niceties of Python. It prints out what the number is, and it prints if it's even or odd. Pretty simple function. And then I have a while loop, and it takes in user input with the prompt being, would you like to generate a number, y or n, yes or no? And it assigns it to a variable called user input. So by default, input is going to return a string that was entered into standard in. And in this case, I use a conditional, the if, to well, first I lower it using the .lower method. So if you .lower a string, exactly what you would expect, it would return a lowercase, all lowercase letters of that string. And if it's, it checks if it's equal to y using double equals like you would in most other languages. And if it does, it calls my defined function with a random. I'm accessing the randint method of the random module, and randint takes two arguments, a lower bound and an upper bound, and it'll generate a random integer from the lower bound to the upper bound. It'll call that, and it'll do exactly what that function did that we defined earlier. And if the user inputted an n, that means that they don't want to have a number be generated. So it'll exit the program using the break keyword, similar to most other languages. That keyword does what you'd expect. It breaks out of the current loop you're in. And I have an else, which is just catching everything else. So if a user enters something that wasn't y or n, it says invalid input, and then it goes back to the top of the loop. Yeah, let's hear questions.
So is the random.randint, are the arguments inclusive or exclusive range?
I believe they're inclusive. Don't quote me on that. But again, a good thing of Python is this is all very well documented. So if you're using VS Code or something, you can just control click on the function that you're trying to define, and it'll tell you exactly what it's expecting as arguments. And if you're not, Google will tell you. Any other questions? Cool. So yeah, that's just a rundown of the basics of Python. Basic things to remember, easy syntax and indentation for code blocks rather than curly braces. But other than that, it's pretty similar to most other languages you've used, just with more modules at your disposal. Cool.
Awesome. Let's get a round of applause for John.
Yeah.
Thanks, Josh.
Okay, yeah, totally. Perfect. So you can just close this window, and then you can pull up the command prompt.
Yes, that's AI generated. Thought you guys might like that.
We love AI.
Yeah, AI go burr. But I'll be going over some basics for offensive Python, and just kind of some of the libraries that you can use and some tools. So what are we covering exactly? We'll hit on virtual environments a little bit. I'll explain what those are in a minute. We'll also be serving files via HTTP, getting those files via HTTP, a basic web fuzzer, and kind of how to use the request library, accessing other services with Impacket, and then a little bit of binary exploitation, just like the very, very basics with Pwn tools. And it's all in Python, and Python Go super burr. Eventually, it can be slow. Gotta start with some memes. Up here on the left, it's the anti-gravity XKCD, about how all you have to do to defeat gravity is just import anti-gravity. And the one on the right here is about package management. Like Josh mentioned, it's easy to use and fast, relatively fast, to set up like a proof of concept. But package management sucks big time. All right, before I get into virtual environments, I'm going to dump the scripts zip into Discord. I don't know, we'll find out. Come on.
Discord.
That seems to like it so far.
Well, what's Windows Defender?
Defender's off. Defender sucks.
I doubt it.
That's fair. It should be fine. Let's find out.
Yeah, I think I checked the revenue share. That's not big enough. Right about you.
Oh, it's on. All right. So if you want to follow along, I'd highly recommend being on a Linux machine. If you have a CaliBox or a WSL instance, I would recommend being on there. If not, no worries. I'll still be walking through how all these work too. So virtual environments, as mentioned before, Python package management kind of really sucks. A virtual environment just creates an isolated Python environment for you, where you can safely install whatever Python modules you want without breaking things your system may rely on, because I think Linux does that for some reason now. So to actually do it, so install it with sudo apt-get install python 3-virtualenv. And then once that is installed, run this second command, which is virtualenv / whatever you want to call it. And then you're going to call it with source. And I'll split screen this and show you guys how to do that. And I've already got it installed. So I can go ahead and do virtualenv / new venv and let it do its thing here. Maybe. You'd be nice to me. Oh, they got it. There we go. Took a second. All right, so now we can see the new venv directory, and we can go ahead and type source / new venv, or whatever you called it, /bin / activate. And all this does is just activates your virtual environment. I don't know exactly what it does under the hood, but I'm guessing it just points all your path stuff to that virtual environment. And then we are in it. My install is kind of borked a little bit. Usually you'll see right here the name of your virtual environment, but WSL is being weird. Alrighty. So first, kind of a couple big tools I use a lot. So the HTTP server and Updog. No one asked me what is Updog. It's a good joke. Yeah. Not much. How about you? I don't know. Terrible joke. Sorry. So the HTTP server is like the #1 thing I use constantly. I used it a lot in CCDC at my previous school. It's a great way to get files around, and it's just literally just a basic HTTP server. So if you go ahead and type python 3-m http.server, it'll serve anything in that current directory. And we can go ahead and do that here. So by default, it's going to serve on any address at port 8000. And there we go. We get our directory listing. And then you can just straight up like click in it, download some. But this is super handy for when you have like a restricted network or no way to actually serve files or SSH copy them, or it usually works. The arguably better version of that is going to be Updog, which allows for uploading, downloading, and SSL stuff. So if you ever need to like encrypt your stuff between machines, this is great for it. Because the simple HTTP server, I don't think supports that. But to install that, you do pip install updog and hit enter. This might take a second. Maybe. I swear this worked right before this. Weird. I might have it installed already. Yes, okay. Weird. Oh, there we go. Anyways, while this is installing, any questions? Oh, no, all right. There we go. And then to actually run it, you're going to type in Python 3-m, which means module, and then updog. And then it's going to spin it up on port 9090, it looks like. And this is what updog looks like. So it also serves your current directory. You can upload files, which can be a godsend in certain scenarios. You can also download, but it's a lot better than http.server when you need to get files around. Either are valid methods, both pretty good, and I found both useful. All right, the next thing, which is a little bit more into the weeds with the code, is going to be the requests library. This is used for making basically any HTTP request. Super handy for tons of things like web scraping, interacting with APIs, or making a fuzzer, or just any HTTP any. So to install this one, it's Python 3-m pip install requests, or you can just use pip install requests. Both work. There we go. And then I have a few examples for the request library. First is just going to be a basic GET request. So at the top, I'm importing the request library. And we can set the URL to just google.com/images, or really whatever you want. We can go ahead and call request.get and pass it the URL parameter, and it will go out and reach out to that URL for that. And then I made a nice, pretty output variable with a nice output to see how it actually works. We set the R variable to the output of the request.get, and there's a lot of variables within that request.get and methods that have useful info in them. So, where are we at? Let's see. Go ahead and run that. Gonna take a second. You can see that the request went to google.com/images, came back with a status code of 200 and a response length of 21,151. I did have that printing on screen, but it would like go for ages because Google's default page, or at least the images page, is just massive. The next example, which is a bit more hacky or hackery, is a simple web fuzzer. So if you wanted to check for subdirectories and see if they existed, you can do that with the request library pretty easy. There are much better libraries for this, like Dirb or Dirbbuster or GoBuster. There's a million of them. But you can make one pretty easy. So we do a very similar thing, import requests, set the URL, and we also set a source file for URLs to go to or endpoints to go to. So we open that file, loop over it, and then we can create our URL. I should note, don't create URLs like this. It's a bad time, or it can be a bad time. Use the YARL library. So much better. I gotta thank Ethan for showing me that one. It handles all the extra BS because URLs can get funky. With each URL, it's going to try to reach out to the endpoint of the fuzz URL. And then I also set the timeout parameter here, which tells it how long to actually wait for the request. So right now it's set at 1 second, which is pretty slow. So we can set it to half a second. And then if the status code is 200, we can just print that the URL was found, because that means that the page should exist. Otherwise, print that it doesn't exist, or print that the status code. All right, and then I have this pointed at Google as well. Don't run this for like longer than a few seconds, because Google might get mad. And here we go. Kind of ugly output. If you can decode this a bit, we see that /index has a 404, but a URL was found for google.com/images, which was expected. We also found one for google.com/2006. I'm actually kind of curious what's at that. Oh, weird. Okay, that's cool. But that's kind of a not great output. So we can go ahead and patch it up with a little bit of work. This is using something called the Rich library, which makes printing a lot prettier. This is also in the Discord in that zip file. Basically, it's just giving it colored outputs and some more spaces. Oh. Hopefully this doesn't take too long. I should mention the errors, as Josh said, are pretty descriptive. It straight up told me that there's no module named Rich installed. And this can get kind of annoying if you, or at least the no module error can, because if you're having some weird things going on with your Python environment where maybe you have like 4 Python versions installed, you might have some modules installed in some not installed in another, and then you have to deal with finding where those are at. Here we go, it installed. And there's a prettier version of that fuzzer. So it's much easier to actually see that a URL was found and it's highlighted, and yeah, makes life a lot better. Any questions on the request library? Alrighty. So say you don't want to make just an HTTP request. You want to do maybe some other requests like an SMB server or RPC or just anything that's not HTTP. The Impacket library is pretty good for that one. It's meant for working with like network-based services, and you can install it with these 2 commands right here. So sudo apt-get install python3-impacket and sudo apt-get install impacket-scripts. This is a different way of installing Python packages. If you're not in a virtual environment, you can use this and it should work. You can also just do pip install impacket. As for the impacket scripts, I think pip install impacket scripts will also work, but if not, the same command right here should work. And if anyone's familiar with Cobalt Strike, the same people who made that made this library, so it's pretty cool, and it's free. All right, Impacket can get really into the weeds really quick. So I've just got a very basic example, which is connecting to an SMB server, which may or may not be Rains from last night if you were here. So we can just go ahead and Impacket the SMB connection from the Impacket library, set it up, set the remote name, which you can just set to anything at this point, and it worked. The remote host, and then the session port, which is 445 because SMB. His SMB server supports anonymous login, so you can just give it no creds and it works. But if you were to log into like a Windows share with credentials, you can just put them in here, like user pass didn't want to actually put any real creds in there because this is being recorded, and I don't want to leak those. Once you've actually connected, you can go ahead and call the list shares method, which will just list the shares, and then enumerate or iterate over the shares and get the name of each share. You can also find hidden files and stuff, or not hidden files, download files directly from the shares as well. Impacket can do a lot of cool stuff, and as I'll show in a minute here, it's used a lot for Windows and AD hacking. All right. Sure, I've got that open as well. Oh, install Impacket. All right, give this 1 second here. All right, any Impacket questions while this installs? I think it's Fortra.com. Yeah. So this is Fortra. This is the guys who actually made Impacket and Cobalt Strike, and then like a ton of others. What else do they got? They have like a tool that will auto hack your stuff too. I think it's Core Impact, which is pretty sick. All these are paid tools. Yeah, but they're pretty sick. If they released them free, like everyone would use them and hack everyone, which would be a bad day. I don't know. Oh, wow, it did not like that. Okay, there we go. So it gave me an error in here, which is weird. I created a symlink to one of my folders, so I'm thinking that's causing the problem. But we go back and actually run SMB Connect. This will work for the moment because Rain still has the server up. It will connect to it, list the shares, and then save a file. Which, if we look at this file, is a wonderful, truthful statement that ethical hacking is better than CTF Club. Do we think that? Raise your hand if you think ethical hacking is better. All right, that's like half. It's not bad. Yeah, so that's Impacket. There's a lot more you can get into with Impacket. I would highly recommend Googling it. Oh, I forgot the examples. Hold on. So Fortra provides a ton of examples for Impacket scripts, which do a lot of cool things, such as SMB client, which is just a tool to hack SMB things. What was that? So if we connect to Rain server again with SMB client, we can just see the command. We can type shares, I believe it is. See all those shares again, and then use public. ls that, and we get all the files in there. This under the hood is using very similar things to what I just showed you, just it's better written. And there are a ton of other example scripts for like dumping secrets or just passwords basically, and a ton of other cool AD things. Kerber roasting, I believe you can do as well. And that kind of leads us into the next library here. which is Pwn tools, which is used for binary exploitation and just connecting to things in general. It's a great it's a great big library that does a lot of cool things. So you can do Python 3-m pip install Pwn tools, or just pip install Pwn tools. Either work. This probably won't work on Windows, I think. I don't fully remember. But once you have that installed, you can import it with from pwn import star, which will just import everything. Usually that's a bad practice when importing things from Python libraries, because it'll just bloat up your Python instance for what's running. But people just do it this way because it's easier than importing like 500 things. So to interact with I have these backwards, with a local process or spin up your own binary, just call process and then pass it the path. And yeah, these are flipped. Dang, hold on. Just call process and then the name of your binary, and it will just straight up run it. Let me change this to the correct one. And then under that process, if you just call it .interactive, it'll give you an interactive session with it. Oh, nice. Here we go. And some of you might recognize this as the program that Rain hosted a couple weeks ago, and we talked about in ethical hacking for owning a box and finding an exploit. So under the hood, this is what it uses. It uses Pwn tools. I'll show you that in a second here. But if we just type in ls, oh, it breaks because it is expecting shellcode, which I will explain in a minute here. And it just kind of exits. And then it's very similar for if you want to interact with a remote process. So like a process or an application just sitting on a web server somewhere or some server that maybe takes unknown input or whatever. So you just connect to it and it can feed it input and make it do different things. Or if it has a vulnerability, call it certain ways and pass it stuff that'll break it. Should be remote. Here's Rain's exact exploit. This is on his GitHub as well. So what we're doing here is importing pwn, argparse, and time. Argparse just takes arguments from the user when you run it, or when you run the script. It's going to take the IP and port. We're going to parse those args, and then call the exploit function, which will set the architecture to AMD 64. We have to do this for the shellcode. Generate shellcode, which is just effectively machine code, which is just basically compiled code that does certain things. So the shellcraft library is really good for that. I believe that's under the Pwn library, and it will just create the shellcode for us. And then we convert it to ASM. And then we just call the process remotely, send a line of shellcode, and then interact with it, which will give you that shell. So it's literally just calling bin/sh. I've slightly modified it and done a local version, which is a bit simpler. And we can go ahead and run that. All right, it's going to start the local process, switch to interactive mode, and now it's going to give me a shell. So this ran the bin/sh, so if I type in ls now, it will work, and it just ls's. MI, Kali, current working directory, all that fun stuff. The binary and the source code is in there. Rain, I can pull that source code if you don't want it in there. But it's in that zip file as well if you want to run it. Any questions on Pwn tools? Alrighty. And then the last thing I have for you is some other useful libraries and tools. So I have the Munch library, which makes handling JSON data or dictionaries a lot easier. Pathlib, which makes file paths a lot easier because they're often a pain. And YARL again, which is a URL formatting library and makes URL formatting a lot easier. Again, credit to Ethan for those first three because he showed them to me. And then Rich, which is an output formatting library, which helps make your output look not like trash, and then you don't have to use things like ANSI escape codes in the terminals, and they work across Windows and Linux. So long story short, it does a lot of cool stuff and makes your output better. But that is all from me. Any last minute questions or help with anything? Yeah. That's a good question. Do you know, Ethan?
Probably Pathlib too.
Yeah. Me too.
Pathlib 2 is a backport. Oh, so Pathlib is actually. You don't feel like
Okay.
the other three.
Yeah. All right, any other questions? All right, I'm not seeing any. So if you have any questions or anything else, just come up and ask me or need help with anything. But that's all I've got. So thanks for coming, guys.